All right, here we go. So this is the second problem in the connected objects notes. For this problem, we have two boxes. We have M1 and we have box M2. Notice there's no numbers in this problem, and they want us to find the acceleration due to gravity and the tension that's in the string. So to do that, we need to treat this whole thing as one system, and we're going to look at each individual part. So we're going to look at M1, which is the first mass, and M2, which is the second mass. This mass, if we drew a dot diagram for it, a free body diagram, we know that we've got one force going up and one force going down. This one is the weight of the first box, and this would be the normal force of the first box. And we also have, going to the right, the tension on that first box from the string. For the second box, we always do the force of gravity down, so that would be weight of box 2. And then we also have a tension on this line pointing up. And we have to realize that these two tensions are the same. The box will accelerate to the right, this box 1, and box 2 will accelerate down. So we want to get all the accelerations in the same direction. To do that, we're going to take this part and we're going to rotate it up to the side. So essentially what we'll do is we're going to draw dot diagrams here. So there's one, here's the other one, and this is for the first box. So here we go again. This is the normal force. This is M1G, and we'll just call this Fn. So there's our Fn. Whoops. I'll draw that again. And then going to the right, we do have a tension. And so this is for mass 1. For mass 2, what we're going to do is, instead of drawing the tension going up, we're going to say that up now is to the left for us. So this is the other tension. All we're doing is we're making this thing look more like this. We've got our box, we've got our pulley right here, and then we've got our second box. So we've just taken this box and kind of rotated it up. We're still looking at gravity going to the right here, or down nonetheless, but we're just trying to make this in a straight line. So if we have tension here going up, and that's what we drew to the left, notice that in the opposite direction is the weight of that second box, and we know the weight of the second box is M2G. So now we have everything we need in order to solve this problem. Let's make an axis. So we're going to say that this is positive y, and we're going to say that this is positive x. So that makes it a little bit easier to do. So we'll go ahead and make this a y. Okay, so now we need to do a little bit of math. The first thing we're going to do is we're going to say the sum of the forces in the x direction are equal to, and remember this thing is accelerating, so we're going to say ma. And because we need to do it for the first object, we're going to say the sum of the forces for the first object in the x is equal to m1 times acceleration. We'll do the same thing over here for the second box. So we're going to say the sum of the forces for box 2 in the x are also equal to m times a. Let's go ahead and plug everything in for this first box. So we see all the things that we have. This one's pretty easy. The only force we have going in the x direction is just tension. So we're going to say tension here is equal to the mass of the first box times its acceleration. For the second box, notice that in the positive direction we have m2g. We are going to then subtract the tension from that, so that's minus t, and that's equal to, we need to put our 2 here, that's equal to m2a. Now we have two equations. Let's take the t here, which is equal to m1a, and let's just substitute it in for this t. Let's go ahead and move this whole thing over. So we're going to say m2g minus, now remember we said that this m1a is equal to tension, so we're actually going to just plug it into this equation here. That's what we're doing down here. Minus m1a is equal to, ooh, we didn't want that to happen, is equal to m2a. So now let's go ahead and put everything on one side. So we're going to say m2g is equal to m1a plus m2a. My 2's aren't coming out real well. And now we can factor out the a, so this is m2g is equal to a times m1 plus m2. And if we want a by itself, we need to divide both sides by m1 plus m2. So we know that the acceleration here is equal to m2g all over, and then we need to put our m1 plus m2. So this would be m1 plus m2. So now we have an equation that we can use in order to find the acceleration of this system. If we need to find the tension in this system, we could also do that. Oops, we could also do that, but we're not going to here. If we found the acceleration, then we just plug that acceleration in for the tension right there, and that would help us solve. So I'm going to try to get this to do it without all that other stuff. So we can just take this acceleration, doesn't want to do it, and just plug it in up here. There we go. And that is how you would solve for the acceleration and the tension in the string.